So, okay, so this is lecture 16, week 8. And what I said before recording is that this will be the last class in terms of the typical lecture format. From next lecture, we'll discuss different projects where we'll apply what you learn in the live class. So we'll start with something scratch. You'll see that will help you in your own projects when you or critical thinking for different types of applications. All right, so last class today is the more what we are going to learn about is again we are continuing learning about energy. Um, One of the things that we learned today is that how we can produce energy from agriculture waste. Last class we learned about how to get energy from let's say the algae. So, but that there was a disconnection in the sense that you learn how to produce algae from nutrients, but you didn't really know how you can convert that to energy, a different form. Well, you know a little bit about anaerobic digestion. You can use any organic as anaerobic digester source to produce energy or methane. And then methane, you can burn it to produce energy. And there are other ways too. So you can create biofuel. So this is a little bit about that. And the second half, we'll learn more about what kind of energy is produced, waste is produced during energy extractions, for instance, fracking. Okay, again, the same thing. I'm just repeating that quiz 4 is March 4. That's week 9 next week. And that's the last one. Everything covered after the last quiz until this class. Lecture 16 will be part of it. And project draft is due on March 9. That's the first Tuesday of your last week of class. Okay, so just to be confirmed, it's not the same in the syllabus is whatever is written. It's not correct because I extended it. And again, start making your slides that you are going to at least provide that video recordings of your projects before the last class so that we can discuss some of them here. Final paper is anytime you can submit after you receive my comments. But the latest to commit is or submit is Friday in the final week. All right. So first thing is let's discuss I didn't discuss in recording the quiz solution for the last quiz. So let's go through that. The one of the question was in which water aggregation of nanoparticle will be more likely. So the answer is seawater. The reason is if you think of aggregation increases if your ionic strength or concentration of salt or dissolved sauce or TDS, total dissolved salt, increases. And dissolved salts are there more in seawater, ocean water. The idea here is that any particles has a similar charge, so positive or negative, so they will repel each other. But if you have lots of ions, they will seal that charge. Okay, let's say this is a Na plus. So that means they will not feel that charge anymore. So the repulsion will be less. So that means they are going to more likely to stick with each other. Second question is a biodegradation reaction in a bottle produce methane gas instead of carbon dioxide at the end. What type of microorganism you may find there? Aerobic or anaerobic? So aerobic means oxygen, anaerobic means no oxygen. So let's think of aerobic. If it is aerobic, then you are saying carbon with oxygen. It's usually produce carbon dioxide. Okay, aerobic has oxygen. If it is anaerobic, it goes to CH4. Okay, so that means no oxygen. So the type because it says uh, it produces methane, that means it has to be anaerobic. Definitely not aerobic. So that's the Then the second question or third question was a chlorinated organic is more persistent than fluorinated organic, assuming Both chemicals have similar numbers. So this is a statement. Okay, so whether it's true or false. Think of this way. Chlorinated means it has carbon-chlorine bond. Um, Carbon-chlorine bond. And fluorinated means it's carbon-fluorine bond. So which one is more persistent? It's more about which bond is more stronger. That would be very difficult to break. And the strength of a bond, this is covalent bond, so that means based on at least electronegativity. So fluorine has the most electronegative atom. So that means if it will attract the other atoms more or much more efficiently, or covalent bond will be the strongest. So this is the strongest bond. Then that means the more persistent. So the answer was chlorinated organic is more persistent. That's not true compared to fluorinated. So that's the answer is false. What is the reason a chemical with a branched structure is harder to degrade than the one with linear structures? Assume both have same molecular weight. So if you carbon fluorine, if you think of organic carbons, if you have a lot of this branch, okay, um, branch structure can hinder bond that can break. Branched one has low solubility. That's not, it doesn't have to be. Branch one has too many ends with carbon. That doesn't change anything to do with degradations. Branch structure can hinder the bond that can break. So basically, let's say it's a branch structure, and then microbial enzyme has to break this bond. It doesn't assess the bond very effectively. So that's the one mostly you can explain by that. Root uptake rate is not affected by following factors: transpiration rate, um, concentration of pollutants in soil, concentration of pollutant in water. So basically, the question was, if you have a tree or the roots, how much you think it is going to be infiltrated, or how much pollutant that can move into the roots. Transpiration rate is basically how much water it can draw, and most of the pollutant that goes through root is through water. So that's why this cannot be true. And then think of concentration of pollutant in water. Obviously, that's the reason why it is moving. Um, then remove that one. The third one, or the second one, is concentration of pollutant in soil. So the reason is, so this is the right answer. The reason is, if you have stop in the soil itself doesn't move. Stop has to move out of the soil. So that's why it's not going to directly affect it. Um, uh, so that's why this is one thing you have to. That's the most likely the answer. Phytoremediation technology the best or the least expensive among all technology. Select one. Well, that's just there is no option to think about it. So that's the which is the least expensive. That's if you see that slides, this is where this was more least expensive. Which one of the following process doesn't involve taking pollutant inside plant root? Phytovolatizations, phytoextractions, phytostabilizations. If you see that picture, phytovolatilization means you enable the volatile pollutants to escape to atmosphere. Usually that goes through the roots and then it leaves the system through leaves. Phytoextractions, that's something you basically take the pollutant from soil and you can extract it by harvesting that plant. So that's going inside the plant. Phytostabilization, that's where um, the root system change the pH of the surrounding environment. That way, some of the pollutants can precipitate, particularly heavy metals. So that happens outside the root because it involves changing the water chemistry. So, so this is the answers. Phytostabilization change for water pH. I already explained it. That's how it can stabilize. So the answer is true. The last one, nanoremediation using zero valent nanoparticles. Oh, this type of nanoparticles is more efficient in saline groundwater. So this is exactly same answer, the opposite to the previous one what I discussed. The reason why zero valent nanoparticle will be efficient is when you can deliver it. And the delivery, the biggest problem of delivery is aggregations. Once it aggregate, it removed from the system because it can be filtered out. So that's why it can be more efficient. Um, so that's why this answer is false. All right, so that's the, I mean, nine out of, there are 9 questions, almost 90% of you get more than 9 or around 9, or not 90%. Many of you get, average is around 90%. All right, so that's all for the quiz. Any questions on quiz? Okay, let's get to the topic today. Um, Agriculture waste. Every time, if you produce agriculture, it doesn't have to be just the farm and the plants. It could be also the it's like a pig farm or any other. Also, we let's define them as agricultures. So let's say this is example I show you here. So this is a typical process of involving if you have cow. This is the cow cattle farm. So think of what's the different waste management. So if you think of we have water, well water that is being drawn upon because every operation require water. And then you have number two. If you see, there is a waste storage structures. The reason is you have cattle farm here or the boiler house. All those they produce their poops and their all those stuffs goes to here, or whatever the waste they produce that will be stored in this ditch or the structures over here. And then and if you see they also this is a leaching lagoon. That's where you put the mixture of their peas and all the water that being produced when you wash all their waste. So they put all that stuff there, and that can also leak. If it leaks there, and then it goes to discharge into the stream, and then the stream will have water that is extremely polluted. And the biggest pollutants here, mostly the concern is nutrients, but there are also pathogens. But pathogens are easier to remove if you disinfect and all that, because you can kill pathogen by drying stuff. But it's very difficult to remove nutrients. So the biggest things that you can get away from here is nutrients. How you can get the nutrients out of those locations so that it doesn't pollute the system so these nutrients can always go down. Nitrate is particular, and then also some degree phosphorus, but most of the phosphorus is easy to remove. So this is the whole management of how we can see where the pollutants are or the resource are. And then another type of agriculture waste is if you don't have animal farm. Let's say you have a typical vegetations. So you get these raw straws. So these straws. This is a dry vegetations. And then you have this is a food waste. Okay. So these are different types of waste that we can. These are the things you have to see how we can manage it. A lot of times, if you think of how different farmers manage it, well, many of them really remove them and use for different products. But if there is no way to transfer it, because it requires human labors and all that factors, particularly in developing country, they burn all those. So if you burn them, it produce obviously carbon dioxide, and then you have what is remaining is ash and black carbon. This ash and black carbon has some nutrients capacity. So that's why they burn it at there so that the land can be fertilized. But at the same time, it produces lots of carbon dioxide or carbon monoxide. That's why if you remember and if you hear story about Delhi's, in Delhi, New Delhi, in the capital of in India, in that city you have lots of air pollutions during winter, and the cause of that pollution is not necessarily automobile. It's because of all these farming activities where they burn all that stuff. So it becomes air pollutants a lot. Food waste, as you said, we already learned how to manage food waste. You can manage food waste by using anaerobic digester. And then you have this chicken farm. It has lots of, the biggest waste is chicken poop. And in fact, you can take this chicken poop has lots of phosphate. So one of the best way to manage it is you can make biochar. So if you take the chicken poops, then you can um, pyrolysis. If you pyrolyze it, you can produce biochar with high phosphate. And if you remember, phosphate is very extremely difficult to get because these are the limited. The phosphorus is not a cycle. It has we get most of the phosphorus by mining, and there is a limited amount of phosphorus available. So that means we can reuse them by this process.
Professor,
Yeah.
in general, how does like animal like excrement management differ from like human like discharge management?
Okay. So, well, if you're talking about animal poops, those are, that's just the animal poop is just the less psychologically, it's it's everything has pathogens, whether human poop or animal poop, but composition wise, it all has nutrients, nitrogen, phosphorus rich. So that's why animal poops are used for composting, whereas human poops, obviously that's something is, it's a psychologically bad things for us, so we don't really use as any kind of nutrients. But in returns, if you think of how this actually happen, if you most of the human poops are actually goes to wastewater, and that wastewater turn into biosolid, and then those becomes fertilizers. So it goes through a certain process. That way you remove a lot of pathogens. But I don't think, humans, we are not really, we can't manage this way. That's why that's the only difference. Did this answer your question or?
So it's like less processed, like animal poop is less processed than
Yeah. And also, if you see, this is the only possibility here is because you have so many animals used as in one locations. And that's the
and
reason
like
it's
they
easy to manage.
produce so much waste, so much more than humans.
Yeah, we
Accumulate.
we just plus everything, so that goes to wastewater. Um, but I think, in if you think of, let's say, here we have wastewater treatment system. Let's think of the places where there is not it's not centralized. How they can manage human waste? Let's say if you think of a rural area where look different people live in a different part of the countries or the rural areas where there is no connection develop, or making this pipe network is more expensive. Then what you do is they use septic tank, which is the same concept as this, where the idea here is that you have a home and all the waste, because there is no way to connect them like here, like pipe network, because that's not economical because they are so far away from each other. They produce septic tank. So basically all the waste goes to this is the underground tank, and so everything goes there, so it fills the waste, and then you have a system where which prevent any kind of percolations, or at least filtrations. So then this become like anaerobic digester, the system on the way it is operated. So once it's filled, it takes many years, obviously 10-15 years. Once it's filled, then you replace that with another locations, but we don't use it. So that waste is already That's the reason, because of the psychologically nobody want to do anything with that. But for large city, we use it as a biosolid, so we are applying those back. And this is another type of waste. This is the lagoon I was talking about, where you all these when they wash the, if you have ever visited any cattle farm, they live there, so they live there means they are not going to go to restroom. They will not say that, okay, I go to restroom and I'll go there. So they'll do a poop there, and they pee there, they poop there. So they have this water system where what they do is the farmers uh, they they clean the floor by using water. So that's why they have to remove the cattle, and then they clean the floor, then they'll bring back them here. And those water, mixed water, that's the wastewater, is dumped into this system like lagoon. And as you see over here, that's not because of the waste. It's because of the bacteria or pathogens, certain type of algae that grow here. That's the one algae that doesn't look like a green. Uh, so you see over here. But there are the biggest challenge here is not the pathogens, because you can remove them from a treatment system. The challenge is the antibiotics and hormones, and particularly antibiotic resistance gene, because a lot of these animals, they take antibiotics, so much higher concentration than needed, and so those are gone in the waste. So if you have lots of antibiotics in this waste, any bacteria live there, they are conditioned to that system. So they develop this antibiotic resistance gene, or the defense mechanism. So that means if those spread around in the world, then these pathogens, if we get infected by these pathogens, we can be cured when we take the same medicines that we do normally. So that's why this is a really big challenge nowadays. So we call that antibiotic resistance genes, or antibiotic resistant bacteria. So this is what we call superbug. Okay, if you heard about any um, news, superbug means it's not like big size. It means that normal medicine that we took to cure ourselves, that will not work. That means if you have, let's say, you have a cut, and that cut we heal very quickly. That's because we can add that antibiotics on the screen. We can add that to cure ourselves. But if these antibiotics is not going to work anymore, it's very difficult to even heal simple wound. And just to give you an idea, human antibiotics, there are only three or four kind in last 50 years or 100 years. So it's really expensive or difficult to develop antibiotics. So once we run out of those antibiotics, we can't, the bacteria evolve faster than we can develop antibiotics for. So that's why this is a big concern now, how we can minimize these resistance genes to become common. So that's one of the our professor, one of the colleagues in our department, Professor Jenny J. She is working on this particular field much more than any of us. All right, so this is we discussed this one, how the waste is being managed. So the solid goes to here, as you see over here, solid waste that goes here, directly applied to the field as a fertilizers if it is pathogen free, if it is dried or any possible way. Otherwise, it can be kept in locations and disinfected, and then it will be applied. But if it's a liquid or mixed liquid, then you have to put in a lagoon. And some of them you can also put in a digester or storage structure before you discharge into land applications. Again, this is feasible if there is no antibiotics, no hormone, all that stuff. But if there is any pesticide, not pesticide, antibiotics and hormones, then you don't want to apply those in the agriculture, because then you are spreading the same thing. Basically, you are taking the medicine without even being prescribed to. So that's one of the challenge. And for all these things, you can produce waste, or you can be exposed during production, collection, and transfer, and all that. So just be aware of those aspect as well. So this is just to give you the amount of food loss, which is another agriculture loss, because almost like 50% of what we produce is wasted. If you think of worldwide, the reason is unlike US, many developing countries where a lot of people lives, they do not have cold storage. So that means any seasonal food they produce, they have to eat it, and there is a limit how much they can consume. So that means most of them get wasted. And then also, even in country like US, where many foods, because of the supermarket, all that stuffs, we tends to buy the products which is very much specific. Look how they look, all that stuff. So that means even a carrot which is perfectly fine, but just because the shape is a little bit curved, those get wasted. So it's really lots of waste, and before even it come to the consumer. And again, once it comes to consumer, then there is another type of waste. We buy a lot more than we need, or if you buy and we forgot to cook them, then it become waste. And then also when you cook them, we don't eat it, then that become waste. So food waste is typically a lot more than what we which is amazing if you think of how many people actually have dying because of malnutrition or lack of food. And here we are wasting, like it's not like any, it's just one country, it's many places. It's just the supply issue as well as um, transportation to right locations. So this is just, we discussed that before. I just wanted to reiterate that if you have food or all these food that produced in home or business or any other restaurants, you can, if they are biodegradable, you have to manage or find a way to transport them. If you transport them to a location where it can be reused or used for energy harvest, then that will be useful. So it goes through some kind of pre-treatment, then pasteurization. That's just to make sure there is no pathogens, or it can be used for longer time or stored for longer time. Then it goes to digester. Digester that you can call an aerobic digester, anaerobic. And then it produces biogas, and those gas you store it, and then you can heat it up or in the engine to produce energy. That energy can goes to electricity, and that can um, have lighting. And then also after digester, you have a waste product. Every digestion has also produced some kind of waste, solid waste, that can be used as a nutrients or fertilizer. So this is different process. You separate liquid and water, and then it becomes solid nutrients. Then you apply on the farm or park, and then the park will produce the organic waste or biofertilizers. Then you produce food productions, and those food goes to restaurants and everything else. And some of them also food can directly go to digester if it is a food waste. And then any natural gas you produce, this can also help supply energy or fuel for automobile. So these are, as you see, this whole thing can be sustainable if the key here is this: how do you transport the food waste? How do you collect them, the high amount, so that you can produce energy? Not any other press. Every other things are much more manageable. Um, so there are, we talk about different current technology. So you can, anaerobic digester, we already discussed that. So I'm not going to say again. Um, so I know that there is, this is something I do in the class. So it's not relevant to, maybe we can do it after the class, where we can discuss, different new ideas how to manage food waste or challenges. For now, let's go through this all these slides, then we can have discussion and make it open-ended. So as I said, all this waste, this is just the one cycle, how we can produce food waste and energy. But it doesn't have to be just food to energy. It can be multiple stage. Food can make something, and then that can be used, and those waste goes to the another productions. So all those steps can be done. So that's why there are different options. For instance, plant waste. Plant waste doesn't have any pathogens, doesn't have much contaminants. So it's a lot easier to produce, let's say, black carbon or biochar as filter materials. Then you can also, if it's a lot of liquid, you can treat them as a wastewater, or you can create algae or something that we learned in the last class. And then the remaining products, if it goes to digester, most of the stuffs are already produced, or the carbon become, you remove carbon as a fuel, methane gas or fuel. Then every carbon materials, if you think of our body, 100%, the typical ratio is 110 1. So this is carbon, this is nitrogen, phosphorus. So this become methane or biofuel. What about nitrogen, phosphorus? This become fertilizer. Okay, so that's the whole idea here. So if you don't want to do any of this, you can burn all them or pyrolyze them, and that produce biochar. And so biochar is a carbon sequestration products, in the sense is, if you just leave all this food waste, it become carbon dioxide or methane gas within few days. Whereas if you make it biochar, the carbon is locked for next 100 plus years. So that means this carbon will not go back as a carbon dioxide anytime soon. So you are disrupting that cycle. That means you are keeping more carbon as a solid, as a sequestration products underground. Um, so I think that's all for in terms of the food waste. So now let's discuss this one. Again, this is open-ended discussion. So what we should do is, uh, think of some challenges or solutions. So let's think of some challenge. What's the first? Team A, B, it doesn't matter, because I can't see who is the team A, B right now. So let's have a discussion about what's the biggest challenge you guys can think now that you learn how this is managed. What could be the challenge for food waste management? Challenge and opportunity. Let's write this way. Not team A, team B. I'm going to write what's the challenges and opportunity. Opportunity means solutions. Okay, so any whatever comes to your mind, it doesn't have to be any order.
I feel like a big challenge for like on the consumer end waste is that it relies like sustainable management of food waste kind of relies on the consumer deciding to like compost their foods rather than send them, just put it in the trash. And it relies on the consumer being knowledgeable enough to understand what things can or can't go into the compost.
Yeah, I think that's where it starts. But let's think of who is the biggest, or not. Let's not say consumer. It's more about who is the biggest producer of food waste. Uh, consumer like us, single house are definitely food waste production. But what about other? So consumer or producer. Let's think of what are the other producer.
Like restaurants and other food industry.
So think of restaurants. That's a big one. And then the big the uh, Ralph. So supermarkets are one of the biggest one, because they have a certain guidelines about how long they can put on a shelf. So whether it's a bad or good, they remove them. So that's that's perfectly healthy food, and it's nothing goes bad. It just because it doesn't look good, they want to keep all the time fresh, so they always replace it. So this is one thing you can think of. Every day you go to Ralph, you see everything fresh. How that possible? Because if you put in the refrigerator, it doesn't look fresh after a point. So that's exactly true. So they don't put, once they put it there are certain time they have a they have a certain days, they have to remove. because they don't want to keep something look bad, because that way that will deter other consumers to come there and buy products. So they waste it. If nobody buy it, they will waste it. So the biggest waste is actually the supermarket, not the individual consumer. Once we buy it, it's not that we buy and we throw everything. We still consume some of it, but there is the biggest opportunity there. So supermarket, and the reason why they do that way is because of uh, the the idea of a supermarket itself is not sustainable. If you have a many small business, they tends to manage their food much better, or the products, because they know how much they need. They can manage that one. They can also, so the small farmers system will have less food waste than the large farmers, because they can detect what they need. So for instance, they have this, they buy a bulk amount from a farmer. So they dictate what kind of, how they look, how the carrots should look. So there are a lot of other food, even though they are perfectly fine, farmers cannot sell it. And because they have contract with the supermarket, they cannot sell even the other products to somebody else, because that will lower the cost down. So it's really, it's an interesting or difficult way to manage it without really solving in a different way. So that's one thing. And then obviously restaurants waste, and then consumer waste. So if you have to, this is also opportunity. So if you think of what who produced the most, where you can use it, then there could be alternative way. So the opportunity is like that. So instead of targeting individual home, which is very difficult to do, because imagine if somebody say that, give me your food waste, where should I put it? I'll put in my trash bag, right? So that trash bag doesn't have just food, it has so many other stuff. So that kind of lower the value of that food waste. It's not going to go there. So it's very difficult to do anything from that compared to restaurants or per se supermarket, because that's easier to manage. So when you target this kind of system, you have to think of where you can make a biggest difference in that way. And the second thing, let's say supermarket. How do you manage that? You know that there are certain amount of waste produced by supermarket, and it's their interest that consumer will buy the new products, not using the old one. Uh, so that means what they do with those perfectly fine carrot, after 3 days or 2 days they have to dispose it. So they cannot sell. If they put another shelf saying this is half priced, everybody will buy that one. Okay, so that their profit will go down. So it's their best interest not to even use it, to throw it. Uh, so that means there is a lot of opportunity for a new startup where they can connect with this different this supermarket and get those food that's perfectly fine, and maybe create a company where they can use those some products for either let's say homeless shelter. There is always there is a need for those food, so they can use those products because it's going to go waste anyway. So they could just take it, and then there are multiple pathways here to instead of throwing out all those together. Any other uh, challenge opportunity?
Don't farm subsidies kind of incentivize overproduction?
Yes, that's, I think the subsidies is important because farming is not is farmers depends on climate and many other factors. So in those subsidies helps the farmer. So that's not the problem that farmer produce a lot. I think it's the supply issues. So if you can, if there is a better way for that food waste to be taken from farmers and deliver such a way that the average food cost will go down, that's that's the better way. Because if you pay for more expense for the food, you are obviously stressed in some other way. Food is also a big part of the our expense. So I think overproduction is fine as long as we can actually deliver it to the locations.
Yeah.
But it's a
But
good thing.
yeah, I was also going to say like transportation. So like if you have,
Yes. I think one of the things which is you don't probably realize how lucky We are, in the sense who lives in US, is the excellent transportation system or network. The freeways or highways, these are the best part of the technology here, or the economy. If you don't have the freeway, imagine the cold weather. Once they know that cold weather happens, so many traffic stops because of the in the big freeway, economy stops. Okay, so that's one of the thing, and second is maybe here is the opportunity for for large scale transport. For instance, railway system is becoming expensive because there is no other way to transport. So maybe this is another opportunity. But again, transportation is a better, there has to be better way to transport or store at the location of need, because where California produce food, lot of food. The lot of places, sit big different locations, they don't produce that. But again, US is doing pretty well in terms of transportation. If you think of others in other countries, that's where the challenges are. So I would say transportation. Another thing you write, subsidies. Um, any other opportunity or challenge?
One challenge I noticed was that in cities where you live doesn't necessarily likely doesn't have like a backyard, it's harder to compost on your by yourself versus like when I'm at home, like we have like a backyard where we can put our compost. And then I was pretty shocked that like at in LA it's like common to just throw it in like the trash
Yes,
because you have to pay extra to compost.
I think this is also an opportunity. If you think of, there's not enough space here, and that's because of congested area, and that's true for any big cities. And that means also we are living very close to each other. So that means if any possible way we can, the community scale composting, then that would be fantastic. If you think of going for, if you've been to um, any national park for camping, you see that different camping spot. You have many camping spot, but they have one location where people can throw all their waste. So that's exactly the same concept. If no, that's one of the things that I was asking in one group, where you can calculate how many people live in an area in a let's say Culver City. How many location you can have this anaerobic digester, where and there will be then cities should have this, instead of trash collections, there has to be a way to get those food waste. But then you have to see the cost. Is this like the amount of, mostly the human resource that needed to collect this food waste, to dump it here? Is this something going to help in possible way? Something um, to offset the energy cost. And so that's one thing to think about. And mostly it's not economical. That's why it's happening, because the human cost is much more. And also food waste, the biggest challenge is also pathogens. If you have pathogens and smell, if you have food waste for a long time in one place, you don't want it to be for long. If you create germ and all these stuff will form. So that's another thing. That's why it is difficult a little bit, but it's doable if there is a better way for the waste to be collected. That's why it's not been done properly. Any last thought before we have a break? Well, excellent. One thing is that this is how we're going to discuss about different problem in the next week. Okay, so I'll put some problems and then we'll discuss it like open in a discussion. It's not doesn't have to have any process. All right. So when we come back, let's have a break for 10 minutes. We'll meet at 5:03, and we'll discuss about different waste produced during energy extractions. So energy harvest is not necessarily waste free. The same way waste process is not energy free. So we'll discuss about that. That way, which what's the actual true cost of energy harvesting. All right, so we'll be back at 5:03. Okay, so one thing we have been discussing so far is how to manage different types of waste, or more importantly, how different waste can be used to produce energy. What we don't realize that every energy production might also produce waste. So that's why there are some energy we call clean energy versus another which is not. For instance, if you there's a perception that solar energy is clean because you're not using any raw products. There is no the resource or the most important source of energy is sun, and you are not really sun is not producing any waste or light is not producing any waste. But to create materials that require solar energy to be harvested, which is solar panel, is a lot of waste. The production of solar energy is consume has carbon footprint, and then once you apply those all these solar panel, how long it will last? What it will do with all the waste. So there has to be some life cycle assessment for that. Then there are other types of waste. If you think of petroleum, the extraction of petroleum and purifications, all that has lots of waste. So that's why every energy production, if you think of the biggest energy production here is coal, and coal produce lots of waste like coal ash or fly ash. So that's why it has to have important way to manage this waste. So these couple of slides will discuss more about how to manage this waste during energy harvest. So for instance, here example I gave you is thermal power plant, where coal is the raw products, where you burn the coals, get the heat energy that creates steam, and the steam will use to produce electricity or turbine. So the biggest waste that you get is carbon dioxide. So CO2 goes there. What left over is ash. Okay, the fly ash. So, but fly ash can be used in multiple different ways. So if you see, what's the different? What's the common between these two pictures? Anybody can say? Guess. What's common between these two? What do you see over here? Left side is a buildings and filled with all these coal ash. Okay, after a spill in Kingston fossil plants in Tennessee. And the right side, you have this big colosseum. Take a guess. The one of the word is used in between those two caption.
Is it that the Romans used different forms of ash in constructing like their buildings as the type of concrete they used?
Exactly. So if you think of what they use to make this big colosseum, or the clay they use to make the structure stronger or last for a long time, is made up of ash. Okay. So that ash is basically the reason why people start using or creating cement. Okay, so cement requires lots of these fly ash is in fact used for producing cement. Okay, but it requires very refined, very there is very specific for form of fly ash. So it's not like all fly ash can be used. So that's why once we realize that this is what is being can be used, so most of the fly ash is gone through this process of finding that products that could be supplied to cement plant. So some major portion of fly ash is actually used for cement production now. So this just give you an idea that every waste that you produce may have some use before even you find something else to do. So this is just example, in 130 millions of tons of coal ash was generated in 2014. It's been increasing, but over time we are lowering the amount of energy produced by coal ash or coal. So that as it decreases, the amount of coal ash, all those is going to decrease. So this is no longer, I think it's declining. The more, at least in the US, the coal power plants, the number of coal power plant is a lot less. In fact, in California, I don't think any coal-based productions. Okay, so so what is in the coal ash? If you think of that, it's basically, it has many inorganic minerals. Okay, so it's a calcium hydroxide, calcium carbonate, all that inorganic sodium, calcium carbonate, or magnesium carbonate and oxide hydroxide. So that's why ash is very, the pH is very high. It's around 11 or 12. That's the reason also cement pH is high. If any water goes through cement, that's the pH is alkaline, around 10 or 11. So if you get concrete and put those in water, the pH will rise because of this ash. Okay. But so this is, if only those things are there, it's not a problem, but it has lots of metals. In fact, if you think of our body needs some micronutrients, those are mercury, arsenic. These are a little bit, very small amount present in our body. And particularly, the fish and all that, they accumulate the mercury. So uh, plant has also some amount of mercury. So that's why every time there is a wildfire, you see a lot of spike in mercury concentrations. So those, once you burn all of that, so 90% of 99% of mass is gone. Okay, all the carbon is gone. So what's remaining is concentrated form of this inorganic. So that's why the concentration of heavy metals is much higher in ash because of that concentration process. So all these ash is loaded into river or disposed, you'll have all these metals. So you can see this picture over here. That's what they do. If you have a power plant, you create a big ditch, and that's where you dump all this ash, and you best create this wall that should protect it. But over time, if you have much rainfall and all that stuff, the wall, if that wall fell, that's how the whole entire ash, tons of ash is going to be washed up. Um, but one of the things I want to say is that coal ash has more metals. If your soil, let's say you are buying a properties and the soil has that much metal concentration, it will be considered hazardous. Okay, so that nobody can live in that area. But so that means those soil has to be disposed into landfill because this is such a hazard. Coal ash has much more than that metals, but it's not hazardous. So I can see that the reason behind it is not about science reason. It's mostly because of economic reason. If you make those coal ash as a hazardous substance, now all the coal power plants will go bankrupt because now they are producing this ash which is hazardous. They have to pay for it now, so all that, it will become very, very expensive, and then you will pay much more for the electricity bill, all that stuff. So you can see that there is always policy decision when it comes to coal power plants as coal ash not being hazardous. So it's not really concentration reason, it's more other reasons. So we keep talking about coal ash, fly ash, bottom ash, boiler ash, slag, all that. So you can see that in this picture, it explains where it is are. So the coal in this picture you see over here, the coals are conveyor belt that takes the coal out from the systems, and then it put into the boiler. That's where you burn it, and those get the energy. Coal has high energy, that's why it is being used, high BTU. And then basically the ash will, bottom ash means everything after burning, those things will come down. So that's the bottom ash. And then when you're burning, the temperature is so high that you are creating this fume. So very fine particles, smaller than 1 micron or around 1 to 2 micron, will fly across. So this will go around here, And so that's why it's called fly ash. It's not because it's a different reason. It's just because it fly around. Okay. Um, so you have fly ash that goes here. Then there is a this ESP or fabric filter. Basically, it's electric. No, the fly ash has a certain charge. So if it has it develops static charge because fly ash hit with each other, so they are very charged particles with high temperature. So you create this capacitor or the plate so that they stick with that plate. So everything fall down. So that's how you can filter it electrostatically. So that's how you create the fly ash, and this is what actually used for cement. Okay, so this is not coal ash is not useful. Fly ash is useful because that uniform grade, 2 micron size, that's what being used. Then once you leave the system, as I said, the mercury, you burn the mercury evaporate or volatilized. So all the gas that you produce, it has fly ash, but it also has high concentration of mercury. Before the coal power plant release everything outside, they didn't have this system. So that's why many places where they have a lot of coal power plant, you have high concentration of mercury in their soil. If you think of Tennessee, there is a reason why Tennessee River people don't eat any fish there, partly because of this reason. There was no less regulations that time, and also another reason is in World War II times, they are producing nuclear weapon. And so in Oak Ridge National Laboratory, they use as a centrifuge. So the way you can concentrate is you use mercury, liquid mercury, in a big centrifuge. That's where you store the you separate stuffs, separate nuclear, plutonium or uranium. So they use tons and tons of pure mercury in a liquid, big tank, and those are used like normally. There, that time mercury was not a problem, so they can. That's why all those soils are heavily enriched with mercury, and obviously there is always a, and then also coal power plant. So combination of those two operations makes that entire area very toxic for mercury. Emma, are you speaking anything? I see you, but I don't. Your mic is muted. All right, so so the next one, if you see over here, the mercury is separated, and they are released into to environment where those are all become part of the ash pond. So those things goes into those ash will also get into your surface water. So this is just an example of showing, if you have a coal power plant, those are all different processes that goes to the system. Any question? All right, so this is the issue. So if you go click on these articles, that shows this big ditch was there over here. So this wall fell over here, and this how this is all released into the rivers and get into the systems because of these issues. And this is the big news that time, partly because it entirely contaminated Tennessee rivers and polluted most of the area. And there was not much regulations on how they can create this ash ditch and how they can manage those. So lack of regulations cause this kind of accident. This is not the only time it had happens. In fact, this kind of accidents because of coal ash has been happening every 10 years at least once. But still, many states don't have a strict regulations, and that ended up having these issues. So that's why it is important how to dispose it, but most importantly, what can you do to reuse it? So these are the different way I show you. The biggest reuse is you can use this coal fly ash to make concrete or cement, all that stuff. You can also use fly ash. As I said, the pH is very high, so you can use that as a pH, lowering a pH or increasing the pH of any system which where the pH is very high. So if you think which place has high low pH, is the place where you do acid mine drainage. And every time there is a mining operations, it produce because most of the mines are based on sulfide waste ore. Those sulfide, when they dissolve, it become sulfuric acid. That's the reason anytime there is a mining operations, those waste products produce high concentration of sulfuric acid. So those mine waste or the mine acid mine drainage is a big problems in all the mining area. Because of the low pH, you can take all this ash, which is high pH, mix them together so that you can make the pH a lot more balanced. So mine reclamation is one of the reason because of that. So if you click on all those link over there, you should be able to find the different use. And the another thing I want to say is this colas, like anything else, is enriched with rare earth elements. So now Department of Energy has a big incentive about how to extract these rare earth elements from coal ash. And just to give you statistics, rare earth element is used for every smartphone, every electronic device, every car, solar panel, name it, every possible way. And 99.9% of rare earth elements comes from China. So that one country controls everything. So if China said tomorrow that will not give any rare earth elements, everything stops. Okay, and and so that's the reason why US is not producing rare earth element is because the extraction process is very expensive because of environmental regulations. It use high concentration of acid and solvent, and it's not environmental friendly. That's why no country does that. And also, there are not many mountains which you can dig to find rare earth elements. So China has this strategic advantage because of that reason. So that's the reason US or many countries now finding alternative way to get rare earth elements from or harvest rare earth elements from coal ash or coal. So this is a big. So we had our lab had a project. We recently got another project from Army Corps of Engineers, and so we are working on how you can use fungi to produce acid that could dissolve some rare earth elements and lower the cost. My colleague is working on how to use a polymer which is based on lipid like any bacteria has. So this called glycolipid. Basically, they polymerize that substance to absorb on a silica materials or a hydrophobic materials, and those as you pass this rare earth extracted liquid, this rare earth element will stick on it. Then you just separately extract those. So there are many technology. If you search for it, that's another advantage. So I'm not going details about this process, but just know that there are multiple ways to extract these elements. So every waste doesn't have to be just waste. The next one, another energy extraction or the challenge is if you think of fracking. Fracking is basically you're collecting gas which is trapped inside the rock. Before it was not economical because how do you dig uh, several miles below ground and frack them? So because they are trapped inside these rock which are extremely impervious. So the only way to extract them is not just by pump. You have to break them apart so that the gas will escape. So that's as with time that it becomes more economical because of improvement in drilling technology, and also combination of the price of oil. So that's why this technology is used. In fact, that fracking is the reason why US is now number one country in terms of energy productions. So what the process is basically, this is way below groundwater. So that means it's not something you don't have to worry about pollution in groundwater. Obviously, if there is some leak in gas, those gas will, because gas, so it can go up and eventually it can go to groundwater. Mostly that's not possibility. Most of the time is because of the well can leak. So if you see over here, this well, these are casing. So these casing can fail. If that fail, then the gas will leak outside. So that's one of the reason, there's the regulations. But mostly the reason why there is a lot of regulations, or you see if you follow the last news, the election news, where One question was asked to President Biden, if you are going to ban fracking. So you have to think why there is a reason for it. Well, if you think of fracking, it produces gas, mostly gas, which is the cleanest form of energy in the sense you don't have to liquid, so you can convert them to methane. It's very easy to. You don't have to use these big pipes to supply, these oils. So the gas is a lot easier to transport by pipe. But at the same time, this operation itself releases a lot of methane gas because it's not control always. So every operation, whatever you capture, you also release a lot more. And that's why if you think of if you think of Texas, it produces lots of methane gas, which is not regulated, right? So if you think of carbon dioxide, it's regulated in the sense every thermal or the coal power plant, they pay a lot of money for this carbon tax, so that they can manage all that. Whereas methane is 25 times more or 100 times, if you calculate the numbers, methane is more potent than carbon dioxide as a greenhouse gas. Whereas they release all this methane, everything to atmosphere without having regulations. If you spill oil, you have to clean it. If you spill methane, you don't have to deal with it. So that's why all this idea behind it. But the most important thing is, if you see how the fracking works, they call frac fluid, which means it's a mix of water, mostly water, and sand, because the sand is the thing that when you apply high pressure, that's how they break. Once you fracture the system with high pressure, you want those fractures not to close. That's why they use very fine sand to get into those fractures so that the gas can escape. So this frac fluid, which is basically mostly water, 90%, 99% water, some amount is sand, and then also there are some anti-corrosive agents. This is no company is going to give you that they are trade secret, but mostly you can understand the concept. Water, sand, anti-corrosive agent because you don't want things to corrode, anti-microbial agent because you don't want the biofilm to form, because if the biofilm form, that will also clog the system. So combination of that, anti-corrosive agent, anti-bacterial agent, and thinner, all that, and sand. This mixture of organic compounds is pumped at a high pressure to create those fractures. And then if you are applying all this water, when you extract those, initially you get what oil, but you have also lots of portion of those are water. With time, the oil portion is going to decrease, oil and gas will decrease, and the water will increase. But either way, when you pump it, you have also lots of water. So you have to deal with those water. And those water is highly, one thing I didn't tell you here is that the water, the injection water or frac fluid, let's say frac fluid, it's made up of water. That's a 95%. You can check that one. Exact number I don't know. Then I say sand particles to keep it open. And then the another thing I didn't mention is the salt. Extremely highly amount of salt. The reason you use a high amount of salt is because you just answer the quiz. If you have lots of salt, what will happen? And the small fine particles will bind together, right? So there will be not much colloid. So they don't want any kind of fine particle to mobilize in the system, because if mobilize, that becomes clogging. So that's why they use high amount of salt. There is other reason too. So it's extremely high salinity. It's almost like it's saltier than seawater. So think of that. So it's use a very high amount of salt, very high salt. And then you have antimicrobial chemicals, and then anti-corrosive chemicals. Okay, so all these mixed together and being pumped, injection well, and then you extract it. There will be a lot of salt too, because in aquifer. So those aquifer has a lot of salt also. So you get this salty, highly salty soil with the oils and gas and many other things. So you extract the gas, you extract some of the oil, remaining amount will be dumped into these locations. And so what do you do with this produced water? This is what we call produced water. So those produced water is high amount of salt and all that stuff. So they have to manage it. And there is no way to treat it now. It's a high salt. Reverse osmosis will fail because it's a high amount of salt. It will clog very quickly. So that's another economical hazard now. So if you every time they frack for a couple of weeks, they leave this amount of liquids for a long time there, let it evaporate, and then becomes hazard in a way. So that's why this is one of the challenge for that. The last one. Any questions or any?
I'm just curious. So they just leave those basins out and they just let it evaporate until it's a solid?
Yes.
How long does that take? Like on like a big scale?
I don't know what they do, so I could be wrong. So, but point is, everywhere there is this liquid. I have to check with other people. So that's something I don't know yet. But evaporation, I don't think that's the only way. But they leave behind for a long time. So that's another. If you think of these are remote areas, so wildlife, all those things you can think of, the consequences much severe. So that's one of the reasons why this is a lot of times people don't like this kind of operations. It has a big footprint once they leave that systems. All right, the last one is nuclear. This is I think the most, cleanest energy. We talked about that last time. The reason is you use nuclear fuel, which is already extracted because of power all these stuff that for all the wrong reason. But this entire reactor is here. Everything else is not contaminated. It's all just water is being transported. So the main reason why it is nuclear power plant is always near coastal area is because of that cold water from ocean. You can use that water as a circulation, as a coolant, a lot easier. And then or any places which has enough amount of water to cool it down. But there is no other waste. The only waste, if you think of that solid materials, the nuclear waste that after it's being used, obviously you produce this power, all these atomic weapon that has waste too. But at least it's being used. One nuclear it has high energy. 1 kilogram of or one atomic weapon can power the entire California for many months. We can calculate that. So to see the actual number if you search. So if you realize, the energy, the amount of energy we can get from nuclear power plant can actually supply most of energy for many years, on several hundreds of years. We don't need even any form of energy. But again, that's to show that that's just a challenge because the risk involved or also psychologically, that anything goes wrong, the consequence is devastating. So that's why it just not many public support. This is just to show you the type of waste is being produced. These are the nuclear rod that lowered into the chambers. Based on how far it is inside, that will produce the energy. And when you want to lower the energy, you just move the rods out into this liquid to cool it down. So that's why it is always stays there. And then there is a supply to keep it to keep the outside side cooler. So this is just to show you the different type of energy waste with time during extraction nuclear waste. It's increasing because more and more people are using nuclear waste, but they can be reprocessed. In fact, this is one thing you should search online. Because nuclear is such a clean energy. Bill Gates, about many things he is doing. That he's invested in eradicating many diseases. He's also, if that, he's also invested in producing medical device. Because if you think of X-ray, if you do think of a lot of different things, using this nuclear waste after it's being used in this low level of nuclear waste that produced in power plant, they can take them and produce medical or medical applications, these radiation device for medical applications. So this is another thing they are working on, and they have, you can search online. So you can see, if we know what the challenges are, we can really solve many of the waste issues. We just need to have that, mindset. Um, let's see. Let me check because we don't. See if I can see what is this YouTube, because we so far I'm talking about that. We can end this meeting with this watching this YouTube for. But just to give you the, before I finish, let's say, solar energy. This is what I was talking about. You have lots of solar energy. As you see, Arizona has way more. Not Arizona. This is what is this? Nevada. What is AR? Anybody remember which state has AR? Is that Arkansas?
Arkansas.
Okay, right. So if you see these are the different thousands of pounds of what is this? Uh, Toxic substance desalination for 21 versus 26,000 pounds of waste is not available. Okay, exporting Californian solar waste. More than 46 million pounds of waste are created from solar companies in California between 2007 to 11. Okay, so just to show that solar energy is not clean when it comes to producing waste. So we don't account for that a lot. So when you think of solar energy, it also requires the highest amount of water. In fact, a lot amount of water, because the efficiency depends on the solar panel to be clean. So it has to be clean multiple times. And so it requires water, and those water is wasted. So some group are working on how you can use those water. So basically you can apply this water, and those water can drain into a location which can be used for vegetations or some kind of farming. That way you don't really waste that water completely. So there are ways to think of, and make the circular economy.
Question about the components that are making those solar panels toxic. What is it in the solar panels that's making them toxic? And do you have the same problem with like windmill technology for like wind farms?
No. So wind farm is basically it doesn't have chemicals that required for wind farm. It's basically things like turbines. It's the same thing as think of hydroelectric power. So you have a turbine that moves, and that water is what makes the turbine move, and that's how it produces electricity. So wind is clean because of that, because all you have is a biggest fan, so that even at the slowest velocity, the fan will move. That's all the whole point. So that the production doesn't have much chemicals. But if you think of solar, think of your electronic waste. Think of so many stuffs goes there to first that solar, the silicon and all that. That's normal, but it's basically transistor. The photons comes, that absorb it, and the electron jump. That's how they produce electricity. So every kind of electronic waste has lots of different stuff, right? So solar panel has all those. More importantly, it has lots of polymer, because you wanted to make the solar panel um, should not have any biofilm. It should not, no, there should not be microorganisms. So you apply all these PFAS also. You apply PFAS on it because so that it doesn't stick with water and dust. Then those chemicals are there. Then also the material itself has lots of polymer, toxic polymer, and that's being used. So producing solar panel is not cheap. Cheap in the sense not environmental friendly that much. And same thing you have to think of also electric car. We all talk about electric car being clean. Think of this battery. Each battery, every time you dispose a battery, where it goes, how does it manage? If everybody start traveling with electric car, we have to deal with those battery, right? So right now we don't have to think about it, but just think of life cycle assessment, how the waste will being handled. So next time you think of everything clean, it's just ask yourself what waste, where is the waste, and also to produce solar panel, what is being used, because those raw materials require mining and all that. So you have to think of entire cost of that. Then you'll realize, yes, it looks clean because it produces solar, but to make those materials, you have to think of all that aspect of it. So this is just to give you an idea of material throughput is the question you ask. Look at this. What's the materials is used? For solar panel, you cannot just put it like that. You have to use a structure. So cement is going to be used, and, or cement, concrete, and then you have glass. That's the biggest thing for solar panel, and steel, and then you have other type of chemicals, because the structure and all that stuff to hold it, that is steel. So if you combine them together, these are the different materials is used, and each and then you realize to produce all the steel and all the cement, it's also energy expensive. So you spend a lot of energy is being used to make those materials. Whereas if you look at the other extreme, nuclear power plant, you create this with concrete and steel. That's all just to structure a house. Everything else is not waste. I mean, you have nuclear waste, but that's a very small volume compared to anything else you are thinking about. Because because E equal to mc square, the energy is very high for a nuclear weapon. So even a small amount of plutonium will produce a lot more energy. So the volume of waste is a lot less. So this is just to give you an idea, what's the biggest waste that being used. Hydroelectric, you are creating dam, so that means obviously you will use a lot of concrete to produce them. So that's the material cost of it. So that's the whole idea. At the end of this class, I hope that you get a sense of anytime you think of waste or materials or any productions, or any things like that, think of what raw materials is being used, where it's coming from, and also what's the end product, what waste is produced, how it is managed. Then only you can see the actual cost of that productions. So let me see this. I forgot what. Okay, so I'm going to end this class, not now. I'll show you the video. We want to end this class with Bill Gates' visions about how you can use the nuclear energy for medical device. Okay, so I'm going to stop sharing this one, and I'm going to, let's see, there is a chart window. The last slide said the company sued the people for complaining about dumping. William, can you say, I forgot, I didn't see this one until now. Which slide? Slide 25. Okay, I didn't share this one yet, so let's go back 25. Oh, no, well, I'm sure there will be public litigation. It's not that they're doing illegal dumping. They had the permit. It's just they don't have the right or they didn't follow the proper protocols to hold it in place. They have the permit. Every time there is a power plant, they have permit to put the waste somewhere. But then if they don't really have that structure stable, then obviously this thing will happen. Okay, so what I'm going to share is share the let's see, share this video. So share, okay. Okay, so we are going to watch the video for next few minutes.
The French public is more negative towards nuclear energy than the U.S. public.
Even though they're what, 70%
of electricity. We have more nuclear plants than they do. We have over 100 nuclear plants out of 400 in the world. So we are the biggest in absolute nuclear electricity generator. But
you were personally investing in nuclear.
Right. So the plants that are out in the world today are basically generation 1 and 2 plants. There's a few generation 3 plants, including at the conference, Westinghouse, Toshiba talked about the AP1000, which is a Gen 3 plant. That and the Ariba EPR are the two Gen 3 plants. I think you can build a lot of AP1000s, and I think partly because what the Chinese are doing, that has by far the inside track. A lot of those can get built, so that Chinese have this goal of 80 gigawatts. Assuming there's no more accidents, that actually can be done. Unfortunately, because their demand increase is so great, it only gets you up to at most say 12%, best case of Chinese energy. The thing I'm investing in, and not because I expect to make a ton of money on it, it's because I think because it's zero CO2, because the economics are so good, is a fourth generation design. And there are many fourth generation designs. This one is very, very attractive from an economic point of view. I mean, way cheaper than today's nuclear.
Can you, we had Nathan Mervold here last year, but can you explain a little bit about how this technology works?
Okay, basically.
You're just among friends here.
Yeah, absolutely. The part of uranium that's fissile, that is that when you hit it with a neutron, it splits in two, is about 0.7%. And when you break an uranium atom in two, you get 1 million times as much energy as you do from burning a carbon molecule. So you think, wow, this is good technology. It's 1 million times better. Now you have to take that factor of 1 million advantage and say, oh, crumb, that stuff that it splits into, that's radioactive. That's cesium, some bad stuff. Some short half-lives, that means it's intensely radioactive. Some long half-lives, that means that it's around for a long time. So basically, the reactors we have today are burning that 0.7%. And that works fairly well. There was a concept a long time ago that you would do a different type of reactor called a fast reactor that would make a bunch of another element called plutonium. And then you would pull that out and then you would burn that. That's called breeding in a fast reactor. That is bad because as soon plutonium's nuclear weapons material, it's messy. The processing you have to get through is not only environmentally difficult, it's extremely expensive. The concept of this so-called TerraPower reactor is that you, in the same reactor, you both burn and breed. And so instead of making plutonium and then extracting it, we take uranium, the part that the 99.3% that you normally don't do anything with, we convert that and we burn it. So it's like a candle. A candle wax doesn't burn at room temperature. It's the flame converts it to be a liquid and that burns. So this is just like a candle. Our flame is taking the normal depleted uranium, 99.3% that's cheap as heck, and there's a pile of it sitting in Paducah, Kentucky, that's enough to power the United States for hundreds and hundreds of years. You're taking that and you're converting it to plutonium, and then you're burning that. And we have super high power densities. We have total fail-safe. Any reactor that a human has to do something, that's a little scary.
What's the scale? Is scale important here, or is it the same scale?
The TerraPower reactor, the current design is about the same scale. That is typically it's somewhere around a gigawatt type design. Because of the surface to volume ratio things, the first design we're doing doesn't scale down very well. Now we have another design that works for the smaller type, more like 100 megawatt, 200 megawatt design. But our first design, which on paper really works well. And one thing to point out is that digital simulation, and this applies to all these energy technologies, the ability to digitally simulate things is night and day different than in the past. So when they built, say, the reactor at Fukushima, their ability to simulate things was very limited. They wouldn't really know. We take our reactor, we have magnitude 10 earthquakes, we have volcanoes blow over, we have tidal waves passing by, and we look and we say, oh, okay, let's put some more concrete in. You can understand what's going to happen digitally in a way that you never could before. And so the idea of full passive safety, Gen 3 takes us to much, much, much better passive safety, not full passive safety. Gen 4, whoever Gen 4 gets built will be a no human required, no zirconium turning into hydrogen to explode type design.
Timetable for TerraPower?
Right, so I'm going to stop it there. The reason is first, we are almost 1 minute to close. And second, you get the point. Point is generation for nuclear power plants are pretty safe. But I thought that this is also a video about the how to get that waste and produce medical device. You can search Bill Gates medical device nuclear waste. So again, this is a obviously we'll discuss multiple new technology. I'll continue to discuss this new developments about different type of waste alternative used in next class, but also we'll have some time for our discussion so that we will learn together. We can brainstorm about different challenges related to waste and how we can develop newer technologies. And again, I think my prediction is that if you think of the next generation's startups are related to waste. Okay, it's already there. People are taking waste and creating resource, and this is so that's why I say we are moving into a world where we will use everything. The entire economy will be circular. So the more we think now, it will be helpful in long term because your discussion with your colleague or friends, everything you learn, everything you think of a new ideas, like for instance, today you learn that nuclear waste can be a medical device. Imagine that conversation, how many people know about it. So even having that conversation with your colleagues and friends does increase that awareness. So I think the biggest challenge is that the stigma that waste is a waste. I think we should not use that word waste ever. Waste is a resource. And I think that's the main point of this class. So I hope that next 3 class we'll have this conversation a lot more engaging way so that we brainstorm those. All right, so that's end of the class in terms of what we have covered today. I'll wait for a few minutes for you to ask any questions related to projects or anything. Otherwise, we are done with the class for today.